Alright guys, good morning. So good morning everyone, and my team, can you say good morning? And hi to the
Hello, Sir
classmate and
Orville.
Dr.
Hello, Doctan. Hello, everyone.
Alright, so as a whole team already said good morning and have an introduction. You already know us, so we will start with our presentation.
The Philippines is a typhoon-prone country as it is situated next to the Pacific Ocean where storms typically form. These storms, or even heavy rains, often resulted to heavy floods in certain parts of the country. The group identified one of the usual areas of concern, which is the Marikina city. Due to the common problem of the identified area, the recent devastating typhoons, and lack of parameters to mitigate the problem in heavy floods, the group proposed augmented reality-based flood alert and risk prediction system for Marikina City.
Marikina geography. Marikina is one of the large distributions in Metro Manila in terms of land area at approximately 21.5 square kilometers or 2,150 hectares, about 3.37% of the total land area of Metro Manila. The south portion of the city occupies the numerous commercial, industrial, and residential areas, heritage sites, and mixed-use zones, while the north portion are primarily for residential and industrial zones.
Following are the technologies used and their functions. The first one is augmented reality or AR.
Augmented reality or AR is the technology that adds layer of digital information onto our physical world, usually through a camera lens. AR appears in direct view of an existing real-world environment with superimposed computer-generated images. The proposed technology will use an AR mobile application which typically connects digital animation to a special marker or with the help of GPS to pinpoint the location of the areas of concern.
Next we have Geographic Information System or GIS.
Geographic Information System or GIS is a computer system for capturing, storing, checking, and displaying data related to the positions on the Earth's surface. This technology will provide necessary information within Marikina City, for it shows different kinds of data on a single map, such as city streets, structures and buildings, drainage system, as well as the road and vegetation. This enables the user to more easily see, analyze, and understand patterns and relationships concerning the flood-prone areas. The system will use the following features such as maps, GIS data, spatial analysis, and mobile apps.
Another technology is the Global Positioning System or GPS.
Global Positioning System or GPS allows accurate determination of geographical locations. The three main components are the GPS satellites, the GPS receivers, and the complex computer software needed to decode the signals and compute the geographical position of the user. It is usually used in navigation and become of vital importance. GPS will be embedded in the proposed app, which sets up a pathfinder for the users to navigate a safer location by simulating traffic flow provided by GIS. This will ensure a correct path for the users and respondents in times of the calamity.
Then we have image and video processing.
The proposal will also use image and video processing using material recognition technology. It is a process of recognizing the constituent material of the object. The visual appearance of the surface of an object depends on several factors, including illumination conditions, the geometric structure of the surface, sampled at several spatial scale, the surface reflectance properties from set of photographs. The use object detection and material recognition technology will help the proposed app to recognize and analyze housing or building structures which are made from light materials and are prone to destruction caused by heavy floods, especially those houses situated near the riverbanks of Marikina City.
Next one is Finite Element Analysis or FEA.
Finite Element Analysis or FEA. is the simulation of physical phenomenon using a numerical mathematical technique. Complex mathematics is required to understand the physical phenomena that occurs all around us, like fluid dynamics. Analyzing most of these phenomena can be done using finite element analysis as a leading mathematical technique. Flood simulation can be better analyzed by FEA to represent the water flow and behavior. This can provide users with graphical visualization through an AR-supported device. This will help the residents and rescuers of Marikina to have an immersive view on how to defend and respond to the upcoming calamity.
In addition, we have data analytics.
Data analytics refers to the set of quantitative and qualitative approaches to deriving valuable insights from data. The system uses machine learning and data management software. Data analytics will consolidate all the information and systems to be used in the proposed app. It involves many processes that includes extracting data and categorizing it to derive various patterns, relationships, connections, and other such valuable insights from the captured images in Marikina City. Once the data are collected, the system then categorizes, store, and analyze to feed valuable risk assessment, navigation, and evaluation of the area being analyzed.
And lastly, we have the mobile application development.
Mobile application development is the process of creating software applications that run on mobile device. A typical mobile application utilizes a network connection to work with remote computing resources. The main output of the proposal is a mobile app which will encase AR, GIS, FEA, GPS, image and video processing, and data analytics to fully realize the technology to analyze, simulate, navigate, evaluate, and visualize the flood zone areas of Marikina City. It also has a newsfeed scooping to post updates for the users to tag places with flood-caused events such as stranded people and other flood-related incidents. The app will be both available on iOS and Android platform-supported devices. The figure presented shows the conceptual framework of the proposed technology. The data requirements are Marikina GIS and visualization, usually from Google Earth, Google Street View, GPS data from the users, and crowdsourced data from the social news scoping. The software requirements and corresponding skills used are Python, GIS program, MATLAB, Google Cloud Vision, cross-platform application software such as Android developer tools, and AR software. This will be useful to enable technology systems and processes such as data analytics, image and video processing, finite element analysis, application development, and augmented reality development. The output is an AR-based flood alert and risk prediction system for Marikina City.
The figure shows the system block diagram. The data from the graphical information systems, together with data from the users, shall enable the first stage of flood analysis using the finite element. It will determine flood simulations, hazard places such as the water canals, drainage, manholes, and high voltage areas, safe spaces such as the evacuation areas, and high altitude points. It shall serve as the input to the data analytics system. Other data will be coming from the image and video processing systems that can detect light materials from real-time vicinity view and location. The data analytics system will be able to determine risk ratings and flood direction flows that can be visualized real-time using augmented reality. A mobile application would serve as the user interface.
So guys, what will happen if the AR-based flood alert and risk prediction system will be implemented in Marikina?
Expected benefits. Our target beneficiary for the project is the city of Marikina, as history summed up the effects of flooding in this city. The topography of the location shows that it is a catch basin for rainwater due to its low-lying level. The optimum solution for this city is to relocate. But due to the population density, engineers have to maneuver a remarkable solution to isolate or control this flood problem. If the augmented reality-based flood alert and risk prediction system for Marikina City will be placed, the following will be the benefits of the technology. First, AR fields simulation of scenarios caused by flooding for people, environment, asset, and reputation, or PEAR. Second, a realistic approach on risk prediction for the Regional and Local Disaster and Management Council, or NDRRMC. Third, a customizable risk prediction for simultaneous occurrence of disaster or calamities, but this is for future update. Fourth, a real-time forecast of damage based on the demographics and the status of environment, culture of the population, government rules, infrastructure, and other available controls. And lastly, it can serve as a tool for infrastructure requirements such as feasibility study and government policy creation.
Alright, so we're already down with the benefits. So, in the end, there will be benefits, but the local LGU or your target niche, your target market might not be buying your product or services because it's not sustainable, it's not viable, there's no resiliency on the product. And in order for us to showcase what is the viability and sustainability, we have run it down to 4 items.
For the viability and sustainability, Marikina's local government, especially the NDRRMC, would want to take this technology for the following reasons. Number 1, realism. The AR technology will help the local government display to the people what is coming, as this technology is suited for their city. It is customizable and created based on their real-time river capacity, flow of water, controls that they have to mitigate flooding, topography of their city, saturation of the soil, nearby dam outpours, and others. This technology will be a much more deeper dive than just forecasting the weather. It predicts the character or the attitude of the flood and the effects of the typhoon, dam outpour, or high tide to the city. Second is independence and resiliency. The technology caters the need of the city, hence, the data will be coming from the city itself and managed by the city as well. The local government will not need to rely on the national government for early risk prediction, as most of the time, the power to save your city is within your LGUs. This technology will let the LGUs know what they will be facing and be informed if their controls can handle the amount of floodings or rainfall hitting their city. AR will showcase the independence by simulating the outcome of the city, providing results, whether the current controls are effective or additional mitigations are needed until such time that the controls will match the risk level or even exceeding the resiliency of the city. Third is the futuristic feasibility. As AR display the predicted risks via realism, presentation for future requests of the key infrastructure projects can now be simulated in the comfort of the city's office, as data will now be available for the city to manage their future controls. Lastly is the community-based sustainability. The future advancement of the augmented reality-based flood alert and risk prediction system for Marikina City will also be populated by the public or its citizens, just by scanning their phone and their location, getting the view of the riverside, the flow of the water, amount of rainfall, status of river breakwater, and other uploadable media status. It will be a collaborative media platform where the community can upload data to help populate a much more accurate prediction. Imagine your social media having a specific section for current risks in your city, focusing on disaster and calamities, and where the social media notify a specific person what to do based on his or her location, directing people where is the safest location or nearby evacuation area and how to get there.
The design and development of systems, which includes technologies such as AR like this, will be very costly. But considering the lives that can be saved, it is indeed worth it. Table below shows the estimated costs. The proposal suggests that the system design and development shall be outsourced, with critical data shared by into the government institutions such as the DOST Pag-asa, NDRR-MMC, DENR Nabria, and the Marikina LGU. Each system shall include the software license, data gathering mechanisms, and development costs. The GIS development would cost around 30 million pesos. The finite element analysis, 30 million pesos. Image and video processing is 5 million. Data analytics is 15 million pesos. And augmented reality and cross-platform mobile development would cost around 5 million pesos each, for a total of 90 million pesos. While the study proposes the AR technology to provide a comprehensive plan for flood mitigation, it is not a full analysis of the feasibility due to time and presence constraints. Hence, the study would like to recommend an in-depth technology management framework with the following considerations: availability of geographic data for GIS and location-based systems, applicability of data-specific laws and other regulations such as the Data Privacy Act, applicability of national standards for software development, interoperability of responding government agencies, validation of data accuracy, including but not limited to the aerial view and AR view, live feed, safe space, and hazard points, a detailed costing for each system, a detailed software development model such as the waterfall, V-model, Kanban, or Scrum for every system, a set of descriptions and recommendations for each risk rating, a detailed set of timeline for every system and for the overall setup, and a complete system architecture. The availability of data would be the main challenge for the system design, development, and rollout. If the data fed to the GIS is not available, additional cost will be included in the system for data gathering.
Alright guys, so that's everything for our presentation. Hope you enjoy, you learn, and you enjoy the view on my part. Anyway, it is already the season or the holiday, so everyone, we would like to greet you advance Merry Christmas and Happy New Year and holiday, whatever holiday you have for December. So Doktan, baka naman. Thank you. Bye-bye.